Okay, in 11th lecture today we will learn proof of Heron's formula, and I hope the algebra work which was given to you in the homework of lecture number 10 you have completed. If you have completed that factorization and expansion of algebraic identities, then this proof is going to be simple. It is little long but not difficult. So pay proper attention to understand how finding out area of triangle if only three sides are given. So let us consider a triangle whose vertices are ABC, opposite sides are small c, small b and small a, and a perpendicular which we require for finding out area of triangle. The length of that perpendicular is h, distance BD let us assume to be equal to x, and therefore distance DC will be a minus x, right? So this is basic configuration. So here we are assuming that the area of triangle is half base into height, and so delta, let us begin with that only. Delta is the symbol for area of triangle ABC, which is half into AH. So I will keep some algebra ready. 2 delta is equal to AH. So 4 delta square is equal to A square H square. 16 delta square is equal to 4 A square H square. I know we will require this eventually, and therefore I am keeping it ready. Now if three sides are given ABC, if we can find out height of the triangle H, then we can find the area. That is the whole game. So let us see if we can find out H in terms of small a, small b, small c. Now we have two triangles ABD and ACD, which are right angle triangles. Therefore we can apply Pythagoras theorem. Pythagoras theorem implies c square is equal to h square plus x square. Also Pythagoras theorem implies b square is equal to h square plus a minus x bracket square. Okay, so now I can measure h square in two different ways. H square is c square minus x square, and h square is also b square minus a minus x bracket square. So measuring the same quantity in two different ways, I get identity which is b square minus a minus x bracket square. And now if we expand this, what we will get is b square minus a square minus 2ax plus x square, and if we resolve this minus sign, we will get b square minus a square plus 2ax minus x square is equal to c square minus x square. Now this my x square is gone, and we will be able to write x in terms of ABC. Can you see that? So now I want to write x is equal to, so let me jump on to that answer. It will be c square plus a square minus b square, c square plus a square minus b square upon 2a. This is the value of x, and if I have x, I can find out h. So h square is equal to c square minus x square, but x square is equal to this whole quantity. So c square minus c square plus a square minus b square upon twice ab. Is that right? Now it is pure algebra. Actually we have achieved the h in terms of ABC. So if you calculate h in terms of ABC, you should be able to calculate area of triangle if sides ABC are given. But then this is very complex algebraic identity, and it is not easy to remember. Therefore, let us look at some algebraic simplification. Now, what will be the LCM of this whole is 2AB. LCM is 2AB, and is it correct? Not B here, only 2A. 2A. So 2A goes to the this is x, and therefore this is x square. So this is 4a square. Okay. Now 4a square multiplied by c square is 4a square c square minus this is the whole c square plus a square minus b square whole square. Is that right? Therefore, now we transpose this to LHS, we get 4a square h square is equal to, and now you will realize that this 4a square h square is 4a square h square here, which is 16 delta square. So in next step I will write LHS as 16 delta square. What is RHS here? 4a square b square, I can write it as 2ac whole square minus c square plus a square minus b square whole square. So this implies 16 delta square is equal to, this is difference of two squares, therefore I can write them as x plus y and x minus y. Therefore first term is 2ac plus c square plus a square minus b square, and second term is 2ac minus c square plus a square minus b square. Okay. Now if you observe this term, it is a square plus twice ac plus c square, therefore it is a plus c whole square minus b square, and let us write this term by expanding, and so b square is basically positive here, and minus I can say a minus c bracket square. So you just cross check whether whatever I have written is correct or not, but orally b square is going to be positive, and then minus c square minus a square plus twice ac. If we take out minus sign common, then it is a square plus c square minus twice ac, and therefore a minus c bracket square. So it factorizes like this. Now if you look at these two brackets, they are again x square minus y square type, again can be factorized, and hence it is a plus c plus b, that is first bracket factor, a plus c minus b second factor. Here it will be b plus a minus c, and the third factor will be, fourth factor will be b minus a, b minus a plus c. Okay, which is 16 delta square. Right? Now we know a plus b plus c is a plus b plus c is perimeter. Okay, now let us do one more thing over here, that is we have 16 here and we have 4 different brackets. Therefore what we can say, delta square is equal to a plus b plus c upon 2 into a plus c minus b upon 2 into a plus b minus c upon 2 into b plus c minus a upon 2. So every bracket now we have got all the 3 terms a, b, c. In first bracket all positive, and in the remaining 3 brackets one negative. Now let us see what do these terms mean. Suppose I have 3 plus 5 is equal to 8. 3 plus 5 minus 1 is equal to 7. But I don't like 3 plus 5 minus 1 is equal to 7. I would like to write 3 plus 5 plus 1, then do some algebra, but the answer should be 7. So what should I do? I should subtract 2 times 1. Why? Because I have unnecessarily added 1 and originally it was subtracted 1, and therefore it becomes 3 plus 5 plus 1 minus 2 times 1 is equal to 7. Okay. Now here a plus c minus b, the term is present which I don't like, which is equal to a plus c plus b minus 2 times b. Is that okay? And here a plus c plus b I can write as 2s minus 2b. So we know this bracket is semi-perimeter. We know the second bracket as 2 times s minus 2 times b upon 2. Similarly, the third bracket will be 2 times s minus 2 times c upon 2, and fourth bracket will be 2 times s minus 2 times a upon 2. This gives us the final result s into s minus b into s minus c into s minus a, which is delta square, and if we write taking square root of both sides, we get s minus a, s minus b, s minus c. That is what is the proof of Heron's formula. Now you may find that it is very difficult, it is very long, but there are only 2 or 3 steps that you need to remember while proving Heron's formula. One, the algebraic simplification of delta in terms of height of the triangle and base, and then convert it into 16 delta square. Here apply Pythagoras theorem to 2 right angle triangles, and then eliminate h square, which gives you identity in terms of x. What do we how do we find out height of the triangle in terms of ABC? And the moment you get height of the triangle in terms of ABC, you replace it into the first identity, Pythagoras theorem identity, to get h square, and then it is simple factorization, and automatically things will fall in place. So it is not difficult. It is the first proof, fundamental proof, only by using Pythagoras theorem, Heron's formula. A difficult formula which is supposed to be proved, I mean that is what is the image created, is simple, can be done in less than 10 minutes. Hope you have enjoyed this proof. Therefore now we have 2 formulae for area of triangles. One half base into height we have used here, which we have not proved yet, we will prove it little later. But if that half base into height is correct, it is true, then Heron's formula is also true. So we are free to use Heron's formula to solve different problems. Now you will find that there are 10 homework problems, and you might require to use Heron's formula to solve them. Solve those 10 problems. Find out if you have any difficulties, ask us, and enjoy lecture number 11. See you in lecture number 12. Thank you.